This section is actually the last section in the chapter, and what it deals with is inverse of a function, which we've kind of talked about by going through quadratics first and then square root functions and your radical functions after it, because they are in fact inverses of each other. One function undoes the other function, and that's what makes it an inverse. But just real quick, we'll go through the formal definition. So recall that a relation pairs input values with output values, and then an inverse relation will switch them. So the input now becomes the output, and the output becomes the input of the original relation. So what you're doing is just switching those x and those y values, and that's how you're generating the inverse relation, which will be the inverse function. So as you can see, if I have the points -4, 7, -2, 4, 0, 1, 2, -2, 4, -5, to find the inverse of that relation, what you're going to be doing is switching the x and y of each coordinate pair, and then from there, you have your inverse values. And when you graph them, what you'll see is that they'll be reflecting over the line x, y equals x. And you should see that if you folded your paper on a diagonal, that one point will line up with the other point. So another way of looking at your inverse is by looking at inverse operations, and what you're doing is reversing the order. So if you have this equation here, y equals 2x plus 1, what you're doing is you're multiplying x by 2 and then adding 1 to it. So thinking about taking those inverse operations and reversing the order of them, well, adding 1, the inverse would be to subtract 1, and then the inverse of multiplying by 2 would be to divide by 2. So that's one way of thinking about how to find the inverse of a function, is to take your order of operations and reverse them using inverse operations. So what you're doing is undoing the one function to find the inverse function. So inverse functions undo each other. So as you can see, you have your original function here, and then your inverse function is the opposite, is undoing that original function. And because inverse functions interchange the input and output values, the domain and range would then be interchanged as well. So that's why when we talked about for like quadratic functions into radical functions, and you looked at your domain and range, you can see that they kind of depended on one another as well, just like these. Okay, so finding your inverse algebraically. So there's a specific way of finding your inverse algebraically instead of going through your order of operations and finding the inverse of each operation. So what you would do is take your function, and if it is written as f of x, rewrite it as y instead. And then you're switching that x and the y variable. So instead of writing y, you're going to write x. And then instead of writing x, you're going to write y. So you're literally not changing anything but switching the variables. And then after you switch the variables, solve for your new y. Once you do that, that new equation that you get is in fact your inverse of the original. So for example, if we want to find the inverse of f of x equals 4x minus 9, first thing you want to do is switch that f of x to y. Okay, so now you have x and y in your equation. What you want to do is literally switch them. So now it becomes x equals 4y minus 9. So again, all you're doing is instead of writing y, write it as an x. Instead of writing x, write it as a y. Now what you want to do is solve for your new y. So go through how to solve an equation. So you're going to add 9 to both sides first. Then to isolate y, you're going to divide both sides by 4. And that function right there is actually your inverse function. So your inverse of the original function is x plus 9 over 4. And if you wanted to simplify it and rewrite it, you could write it as 1/4 x plus 9 over 4. So again, algebraically, all you're doing to find your inverse is switching the x and y and solving for your new y, going through different order of operations in solving. Now, what you can also do is determine whether or not the function has an inverse or not. So earlier in the year, we looked at the vertical line test, and the vertical line test told us if our original function, or if our original relation or original equation was in fact a function. Now you have the horizontal line test, which will tell you if that function has an inverse function. So more specifically, the inverse of a function f is also a function if and only if no horizontal line intersects the graph of f more than once. So, radical function. Again, remember how we only wrote either the top portion of the radical function or the bottom portion of the radical function. We didn't write both of them because then it wouldn't pass the vertical line test. So at this point in time, f of x, this radical equation, square root of x plus 3, passes the vertical line test. But it also passes the horizontal line test. And because it passes the horizontal line test, we know then that the inverse of this function is also a function. And you should kind of know that the inverse of a square root function is quadratic, which we studied, which we know is a function. So again, because no horizontal line intersects the graph more than once, the inverse is a function. And then here's where the domain and range part come in. So because the range of f is y is greater than 0, okay, because it's above your x-axis, the domain of the inverse must be restricted to also just x is greater than or equal to 0. So the range becomes the domain, and the domain becomes the range, okay? So just like you switch the x and y's, the domain and the range switch as well. So the inverse, which we said is the quadratic, x squared minus 2, is strictly restricted to x is greater than or equal to 0 based on this graph that we were given.